the red hair you occasionally see in Russian populations today. It's not a Slavic trait primarily. It's a Viking legacy. Genes deposited over 1,000 years ago by Norse traders and settlers who spent generations living along those river routes. The Vikings reached even farther. They established settlements in Iceland that remain to this day. Genetic analysis of modern Icelandic populations shows they're a mixture of Norse and Celtic ancestry. The Norsemen who colonized the island often brought Celtic wives from their Irish and Scottish territories. This created a unique genetic blend, combining Norse MC1R variants with Celtic ones. The result: Iceland has one of the highest rates of red hair in the world, a living genetic monument of Viking expansion. They pushed into the Mediterranean, establishing the Norman kingdom in Sicily. They served as mercenaries in Constantinople, forming the legendary Varangian Guard. Everywhere they went, they mixed with local populations, creating new genetic combinations. But perhaps most fascinatingly, genetic evidence suggests they might have gone even farther. There are controversial but persistent studies suggesting Norse genetic markers in populations far beyond their known historical range. Some researchers claim to find Norse DNA signatures in isolated populations in Central Asia, suggesting Viking traders might have traveled the Silk Road farther than any historical records indicate. Whether these extreme claims hold up to scrutiny remains to be seen, but what's undeniable is that within their documented range of expansion, the Vikings were genetic vector, spreading rare gene variants across enormous territories in just a few centuries. The speed of this genetic expansion is what makes it remarkable. Remember, red hair genes are recessive. For a child to be born with red hair, both parents must carry the variant. In a population where red hair variants are rare, the chances of two carriers meeting and reproducing are low. The trait should spread slowly, if at all. But the Vikings compressed this timeline. Their expansion was so rapid, so widespread, and involved so much population mixing that rare variants could spread faster than normal evolutionary processes would predict. A red-haired Viking warrior settling in Ireland might have a dozen children with local wives. Those children would be carriers. When they had children of their own, some of those grandchildren would express the red hair phenotype. Within 3 generations, a single immigrant could establish a red hair lineage in a new population. Multiply this process by thousands of Viking settlers across dozens of territories over 3 centuries. And you start to understand how the genetic map of red hair in Europe was redrawn during the Viking Age. Norse mythology might offer clues to why Vikings seem to value, or at least accept, red hair. Thor, the most popular god in Viking culture, was often described as red-bearded, not blonde, not brunette, red, the most powerful. Most widely worshipped deity in the Norse pantheon was envisioned as a red-haired warrior. Whether this reflects actual religious tradition or later romanticization is debated, but it suggests that within Norse culture, red hair wasn't associated with weakness, evil, or otherness. It was associated with strength, with divine power, with the kind of warrior prowess that every Viking admired. This cultural acceptance might have created something unique in medieval Europe. A population that not only carried red hair genes, but didn't actively select against them through cultural prejudice or persecution. While other European populations might have viewed red-haired individuals with suspicion, potentially reducing their reproductive success, Viking populations apparently had no such bias. The result was a kind of genetic preservation chamber. Red hair variants that might have remained rare or been lost to genetic drift in other populations were maintained, even potentially enriched in Norse populations. Then, when the Vikings exploded across Europe, they reintroduced or reinforced these variants in populations that had nearly lost them. By 1100 AD, when the Viking Age was conventionally considered over, the genetic map of Europe had been fundamentally altered. Red hair, which might have remained a predominantly Celtic trait confined to the western fringes of Europe, had been spread across a vast territory from Iceland to Russia, from Scandinavia to the Mediterranean. The Vikings didn't create red hair. They didn't even originate it, but they distributed it, carried it, normalized it, and left it scattered across the European genetic landscape like seeds from a single remarkable tree. The red hair you see today in populations far from Celtic heartlands, in Scandinavia, in Russia, in Iceland, much of it traces back to those few centuries of Viking expansion. They were genetic revolutionaries, though they never knew it. They thought they were raiding, trading, and settling. But they were also conducting one of the most dramatic genetic mixing events in European history. They were quite literally spreading fire across the continent, and they left us a legacy that's still visible today. Written not in stone or saga, but in the genetic code of millions of Europeans who carry those rare red hair variants. Physical evidence of ancestors who sailed in long ships 1,000 years ago, carrying genes as precious and rare as any treasure they ever plundered. But while the Vikings were spreading red hair genes across Europe, something else was happening, something darker. Because not every culture viewed red hair with the same acceptance the North seemed to. In other parts of Europe, red hair was beginning to be seen not as a mark of Thor's favor, but as something far more sinister. For a long time in our story, red hair had been a kind of quiet power, a visible echo of Neanderthal ancestry, a signal of toughness in low light, cold places on the edge of the old world, a trait that once meant survival. But history doesn't move in straight lines. What once helped you stand out in a good way can, under the wrong culture and the wrong beliefs, become a target painted on your skin, or in this case on your head. As human societies grew larger, more settled, more anxious about order and control, difference itself started to feel dangerous. Anything that didn't fit neatly into the story people were telling about the world became suspicious, uncomfortable, threatening, and few things were more immediately visible, more stubbornly unchangeable than a head of burning red hair. In earlier empires, that flame had often been a sign of prestige, a reminder of far-off lands, exotic ancestry, or warrior blood. But as Europe moved into the long, unsettled stretch we call the Middle Ages, the symbolism shifted. The same visual shock that once suggested power and mystery started to suggest something else: otherness. In a world where safety depended on being part of the right group, praying to the right God, following the right rules, any reminder that you were different could be dangerous. You didn't need science to notice that red heads were rare, that they didn't tan like everyone else, that their skin freckled and burned, that some of them reacted badly to herbs and medicines that others tolerated. People didn't see genes, they saw omens, and slowly, piece by piece, a folk taxonomy of fear formed around them. Medieval Europe was full of stories trying to explain the strange: comets, plagues, deformed animals, miscarriages, unexplained illness. Everything needed a cause, preferably a moral one, something that said, this happened because someone sinned, because someone is in league with the wrong side. Red hair with its uncanny glow slid easily into this mental framework. You can see it in the manuscript and marginal notes in sermons, plays, and local legends. Red hair becomes a shorthand for hot temper, lust, treachery, and spiritual danger. The same fiery stereotype that once meant fearless warrior quietly mutates into untrustworthy soul. Sometimes the associations are almost playful. In some regions, villagers would tease red-haired children, calling them foxes must sparks, little devils, but jokes have sharp edges. The same imagery that seems harmless in good times can turn poisonous when fear rises. And fear was never far away. Famines, epidemics, unexplained deaths, especially of children, created an emotional vacuum that demanded an answer. When crops failed or sickness spread, people went looking for someone who looked like the problem they felt. Redheads standing there like walking embers in a world of brown and black and blonde fit the bill. Some medieval texts and later folklore tie red hair directly to witchcraft. A woman who lived alone, knew herbs, owned a cat, and had reddish hair. That was already a story waiting to be told. If a neighbor's cow died, if a storm ruined the harvest, if a baby was stillborn, that story became deadly. In many trial records, hair color is listed almost casually among identifying details, short of stature, of ruddy hair. A woman of fiery locks, the red-haired widow on the edge of town. It's not proof, not on its own, but it's another brick in the wall of suspicion, another small signal to anxious neighbors that this person is marked, different, perhaps already halfway claimed by darker powers. The superstition bled into other fears too. In some Eastern European traditions, red hair was linked not just to witches, but to the restless dead. Folktales speak of red-headed corpses less likely to stay buried. Red-haired strangers suspected of being vampires or of carrying the vampiric blood. In a world with no germ theory, diseases that struck quickly and mysteriously could be blamed on night-walking revenants. And who looked more like a creature of the night than someone who burned instead of tanning, whose skin flared red and blistered under the sun. These ideas weren't uniform. Many regions had no particular bias against red hair. In some places it remained attractive, even desirable, but the pattern is clear. As fear rose, difference hardened into accusation. The witch trials of the late medieval and early modern periods brought this simmering suspicion to a boil. Between the 15th and 18th centuries, tens of thousands of people, mostly women, but also men and even children, were accused of witchcraft across Europe and in colonial territories. The reasons were almost never simple. Land disputes, personal grudges, economic stress, and local politics all played their parts. But physical appearance matters in any witch panic. A body that already looks like the witch in the collective imagination becomes a convenient screen to project fear onto. Some researchers argue that red-haired women were disproportionately accused in certain regions, though exact numbers are hard to prove. Trial documents sometimes note reddish hair or flaming locks the same way they note a birth defect or a deformity as part of the case for guilt. A mark of the devil didn't have to be a literal claw print. It could be anything uncanny, anything that broke the visual rhythm of the village. In some demonological texts, red hair is listed among the signs that should alert good Christians to the presence of evil. Not a guarantee, just a reason to watch more closely, to listen for any hint of heresy, any rumor of witchcraft, any unexplained misfortune nearby. Imagine living under that kind of scrutiny, knowing that your hair, something you did not choose, could not hide, was silently testifying against you every time a thunderstorm came at the wrong moment, every time milk spoiled too quickly, every time someone's child fell ill. For red-haired women especially, the margin for error narrowed. A sharp tongue, a refusal to marry, a tendency to speak back to authority. Traits that might be tolerated in a brown-haired neighbor could look far more sinister framed by a fiery halo. But the roots of this fear run deeper than witch panics. Long before the height of the trials, Christian art and storytelling had already assigned red hair a particular role, the color of betrayal. At the heart of Christian narrative sits Judas Iscariot, the disciple who betrays Jesus. The Bible says nothing about his hair. That detail is a later invention, a choice made by artists and storytellers. Somewhere along the way, Judas began to be painted with red hair. Red hair made him stand out in a crowd of dark-haired apostles. It made him visually memorable. It echoed older associations of red with sin, lust, and danger. Over centuries, this artistic shorthand hardened into expectation. Of course, Judas is red-haired. How else would you know? From there, the symbolism spread. Red hair became a visual tag, not just for Judas, but for traitors in general. In plays, illuminated manuscripts, stained glass windows, villains and deceivers might be given a reddish beard or coppery curls to signal their role without a word. People sitting in church in dim candlelight looked up week after week at images of a red-haired man handing over his friend for silver. Children grew up with that face as their reference for betrayal. They walked back into villages where one or two neighbors happened to have the same color hair. The connection didn't need to be logical. It only needed to be felt, and it was. Over time, this religious symbolism blended with folk beliefs. In some places, people whispered that red-headed men were more likely to be liars, red-haired women more likely to be promiscuous, unfaithful, dangerous. Again, these were not universal views, but they were common enough to leave a mark on folklore, jokes, and casual insults. Then, as Europe marched into the age that liked to call itself enlightened, the prejudice didn't disappear. It put on a lab coat. In the 18th and 19th centuries, pseudoscientific movements tried to rank human beings like animals in a catalogue. Skull shapes, nose angles, hair textures, skin tones, and yes, hair color. Phrenologists claimed they could read character from bumps on the head. Racial theorists wrote long, confident treatises about which people were naturally noble, which were degenerate, which were destined to lead, and which were fit only to serve. Red hair was swept into these schemes. Some writers described redheads as impulsive, violent, or morally unstable, citing evidence that often boiled down to anecdotes and prejudice. Others tried to map Celtic or northern racial types and ended up treating red hair as a kind of biological warning label. Evidence of a bloodline that was either dangerously wild or romantically primitive, depending on the author's agenda. Either way, red hair wasn't just a color anymore. It was a supposed indicator of your inner nature, your worth, your place in a racial hierarchy that never actually existed in nature, only in the imaginations of those who built it. These ideas filtered down in disturbing ways. Schoolyard taunts, hiring biases, medical myths that claimed redheads felt more or less pain were more or less trustworthy, more or less suitable for certain jobs or roles, none of it grounded in serious evidence, all of it reinforcing an old simple message: you are not like us, and that is a problem. Underneath all of this, the witch panics, the Judas myth, the racial theories is something much simpler and more familiar. Humans are uncomfortable with difference. In small doses, difference is exotic, intriguing. In times of security, the rare and unusual can be celebrated, even fetishized. But when societies feel threatened, when resources tighten, when disease or war or rapid change unsettle people's sense of control, those same differences become targets. It's easier to blame a visible trait than to accept that bad things can happen for no reason. Easier to say, "The devil is at work in that woman with the red hair," than to say, "We don't understand this illness." Easier to paint betrayal onto a redhead Judas than to face the fact that anyone of any appearance could choose to be disloyal. For redheads, the cost of that psychological shortcut was centuries of jokes that weren't really jokes, suspicions that weren't really harmless, and at times very real danger. All because of a tiny change in a single gene. A shift in melanin production that once helped someone's ancestors survive dim northern winters and scarce sunlight. A simple variation written into the human story over hundreds of thousands of years. Yet in the brief flickering span of recorded history, that same variation became a canvas for fear. Fear of witches, fear of vampires, fear of traitors, fear of races imagined into being, fear of anyone who looked like a walking flame in a world desperate to keep everything the same color. And still, through all of this, the gene persisted. The flame kept burning. The story of red hair is not just a story of persecution. It is a story of resilience, of a trait that refused to disappear no matter how much suspicion and superstition were piled on top of it. And as we move forward into royal courts, scientific laboratories, and the modern world shifting attitudes, that resilience becomes even more striking. By the time red hair emerges in recorded history, it isn't just a quirk of biology anymore. It's a signal, a symbol, a thread of fire running through some of the most powerful families on Earth. And what's strange is how often that thread shows up exactly where you'd least expect it. Because remember, the MC1R gene is rare, very rare. In most populations it sits quietly, recessive, disguised under darker pigments. You could live your whole life in certain parts of the world and never see a truly natural red head. And yet, when you peer into royal lineages, dynasty by dynasty, that flame keeps flickering back into view. It's almost as if power and red hair kept finding each other. Start with a simple question. If you lined up every monarch in European history and searched for the ones with copper, oran, or flame red hair, how many would you expect to find? One or two? An occasional oddity? You'd find more than that. Medieval chroniclers mention redhead rulers often enough that it stops feeling like coincidence. William Rufus of England, son of William the Conqueror, was likely called Rufus not just for his ruddy face, but for his reddish hair. Richard the Lionheart is described with light or reddish hair in some sources. In France, in Scotland, in Scandinavia, scattered through the chronicles like embers in an old fireplace, nobility with reddish hair keep appearing. Sometimes the references are vague, ruddy, flame-like, fox-cold. Sometimes they are explicit, hair of shining red. But the pattern is there, rare in the general population, weirdly common in families that ruled. Nowhere does that pattern burn brighter than in the tangled story of Britain. If you close your eyes and picture a red-haired monarch, Most people see the same face, a high forehead, a pale powdered mask, a razor-sharp gaze beneath arched brows, the ornate collars, and the impossible dresses of the late 16th century, the ruff, the jewels, the queen who refused to marry, Elizabeth Tudor, Elizabeth I, the Virgin Queen. Her red hair has become so iconic, it's almost a symbol in its own right. Paintings show it as a structured halo of copper and gold rising above her like a burning crown. But there's a secret tucked inside that image. That brilliant man wasn't entirely what it seemed. By the time she sat for many of those portraits, Elizabeth was aging. Smallpox scars had marked her skin. Natural hair thins, dulls, begins to fade. The young woman whose orb and hair had once shone at Henry VII's court was changing, but her image as a ruler could not. So she turned to artifice, wigs, cosmetics, alchemy of presentation. Contemporaries describe her early hair as a deep, warm auburn inherited from both sides of her family. Her father, Henry VIII, had reddish gold hair in youth. Her mother, Anne Boleyn, is usually portrayed dark-haired now. But some accounts describe her with warmer chestnut tones that could easily conceal a hidden MC1R altitude. Whether Elizabeth's hair was a fully natural red or a bright orange that she exaggerated with wigs, colorants, and symbolism doesn't really matter. What matters is that she wanted to be seen as red-haired. She chose very deliberately to wear fire. In an age obsessed with omens and emblems, this wasn't a trivial decision. Red hair carried contradictory meanings, passion and temper, but also uniqueness, danger, but also charisma. In a world where queens were supposed to marry, submit, produce heirs, Elizabeth engineered an alternate identity. Not a wife, not a mother, but a living symbol of the kingdom itself. The red hair helped. It set her apart from the dark-haired Spanish Habsburg she opposed. It echoed the fierce, almost legendary legacy of earlier flame-haired rulers in the British Isles. It made her look otherworldly, or at least unforgettable. But Elizabeth didn't come from nowhere. Her red-tinged lineage was the product of centuries of interwoven bloodlines, many of them passing through Scotland. Scotland for a long time was red hair's stronghold in Europe. Even today, a disproportionate number of natural redheads trace their ancestry to the Highlands, the lands, and the islands beyond. That's not accident. It's population genetics, founder effects, and centuries of marriage within relatively small interconnected clans. And up among those clans, red hair shows up again and again among the powerful. Medieval Scottish chronicles describe warriors and nobles with fiery hair. The House of Stuart, which would later become the House of Stuart, carried red and tones through multiple generations. Mary, Queen of Scots, is often imagined as a pale, dark-haired, romantic figure. But several sources and portraits suggest her hair had rich or hues, not quite bright copper, but close enough to mark her as different in certain lights. Her son, James VI of Scotland, who had become James I of England and unite the crowns after Elizabeth's death, was said to have light brown to orange hair in youth with a reddish beard. That meant the new king of an expanded Britain was touched by the same flame that had defined Elizabeth's image. Different dynasty, same genetic flicker. This wasn't just aesthetic. In the clan-based politics of Scotland, visible traits were markers of kinship. A streak of red hair in a noble family could signal ancestry, heritage, connection to a particular line. In an age before DNA tests, people used what they could see: eye color, hair color, skin tone. Red hair, rare but unmistakable, became a natural badge. And once it appears in a royal family, recessive though it is, it can linger quietly for centuries, hidden, waiting, then suddenly flaring again in a child who seems to resemble a long-dead ancestor far more than their own parents. You can see something similar if you turn east away from the mist and heather of Scotland and toward the frozen palaces of Russia. Russia, at first glance, doesn't feel like a place where red hair would thrive, but the genetic story of Eastern Europe is complicated. Waves of migration from the steppe, the Baltic, Scandinavia. Vikings becoming Varangians, Varangians becoming princes, princes becoming tsars. Somewhere in that whirlpool of ancestry, the MC1R genre found its way into the bloodlines of Russian nobility. Even the fourth, The terrible is often described in chronicles and later retellings as having reddish or light brown hair and a reddish beard. Other members of the Roericid dynasty show similar traits. These not always the bright copper curls of a stereotypical Celt, but they point in the same direction. Northern European contributions, perhaps Scandinavian, carrying MC1R into Slavic elites. By the time the Romanovs take power in the 17th century, Russia's royal line is already a mosaic. Some Romanov portraits show or reddish hair, especially among collateral branches and extended kin. Later intermarriage with German and Scandinavian houses, where red hair was more common to seed the gene into imperial veins. Here again the pattern repeats. A visual rarity in the general population, yet stubbornly persistent among those closest to the throne. So why did red hair keep resurfacing in royal circles? Part of it is simple genetics. Royalty tended to marry within a relatively small pool of other nobles, often across long distances, but within the same extended network. Once MC1RLS entered that network through a single redhead ancestor or a small cluster of carriers, they could spread silently, hidden under dominant dark hair genes, then unexpectedly appear generations later. It's like a recessive whisper passing through time. No one hears it until suddenly one child arrives with unmistakable fire on their head. But there may have been social reasons too. In societies where most people had dark hair, a red-haired ruler would stand out dramatically. They would be instantly recognizable in crowds, easily described in songs, stories, propaganda. In a world that relied on memory more than photography, that kind of distinctiveness mattered. Some cultures may have associated red hair with divine favor, spiritual potency, or the blood of legendary ancestors. Others may have seen it as proof of exotic foreign connections, evidence that this family had links beyond the local tribe to powerful allies over the sea. Even when red hair carried negative stereotypes, its sheer rarity could make it feel special, and royalty has always been in the business of looking special. Over time, that perceived uniqueness might have been reinforced consciously. Families that produced a celebrated red-haired hero or queen might subtly prefer to marry those who resembled them, hoping to keep the look alive. Portrait painters played their part, amplifying or into copper, turning brownish red into bright flame until the legend outgrew the biology. Was red hair in royal families always natural? Probably not. Just as Elizabeth used wigs and dyes, others surely enhanced what nature gave them. But even the decision to fake it tells us something. You don't imitate what has no meaning, which leads to a larger, more intriguing possibility. Before modern prejudices and superstitions turned red hair into a source of mockery or fear in some cultures, could it have been a quiet mark of noble lineage, a hereditary signal known within certain elites, whispered about in courts and councils, but rarely written down? A color associated with founding ancestors, first conquerors, the semi-mythic figures at the root of dynasties. We can't prove it. The records are fragmentary, biased, often rewritten to suit later politics. But the convergence is hard to ignore. A gene so rare appearing again and again in ruling house after ruling house, from the misty hills of Scotland to the stone palaces of Moscow, the courts of England to the scattered thrones of continental Europe. Perhaps what survives in our genes and our folklore is the fading echo of an older code. A time when a flash of red hair in a newborn prince or princess didn't inspire jokes or suspicion, but a solemn nod around the room. Yes, the bloodline is still there. The flame still burns. Now that flame is scattering again, dispersing into vast global populations, no longer confined to the guarded branches of royal trees. But the old stories linger, the portraits, the chronicles, the queens and kings whose power was framed and sometimes defined by the color on their heads. And as we turn to modern science, we're finally starting to understand what that color really meant and why it keeps surprising us. Now we drift forward again to the quiet hum of fluorescent lights, the soft click of lab equipment, the glow of computer screens decoding code that has been written in our bodies for hundreds of thousands of years. For most of human history, red hair was a mystery wrapped in stories. A sign of witchcraft, a mark of royalty, a curse, a blessing, something to be feared, desired, or laughed at, but never really understood. Now, for the first time, we're starting to see what's actually been going on all along. It begins with a tiny stretch of DNA on chromosome 16, the MC1R gene. You can think of it as a molecular switch. In most people, that switch tells pigment cells, make you melanin, dark pigment, browns and blacks. The same stuff that gives you dark hair, tanned skin, and a measure of built-in protection from the sun. In redheads, that switch is broken, but in a very particular way. Mutations in MC1R flip the signal. Instead of eumelanin, the pigment cells start producing phenylalanine. Red and yellow tones, the burnt orange glow in hair, the dusting of gold in freckles, the pale, almost translucent skin that never seems to tan, only burn. For centuries, that was the end of the story. People assumed MC1R was just a colored gene, a cosmetic quirk, a random roll of the genetic dice. But when geneticists began to look closer, they realized something strange. MC1R isn't just about color. It's wired into a much deeper network. Pain perception, inflammation, immune response, even how your body reacts to drugs. That's when the old stories started to meet the new science. You may have heard the rumor that redheads are harder to put under anesthesia. In operating rooms around the world, anesthesiologists quietly noticed the same pattern. 2 patients, same weight, same procedure, same drug. The redhead on the table needed more. At first, it sounded like myth, a surgeon's superstition. But when researchers tested it, the signal was still there. In some studies, natural redheads needed about 20% more of certain anesthetics to reach the same level of unconsciousness as non-redheads. Other research suggests they may experience more pain from certain types of stimuli, but less from others. It's as if their nervous system is just tuned slightly differently. How? The MC1R gene doesn't just sit in hair follicles. It's also expressed in parts of the brain and in cells that help regulate pain and inflammation. When the gene is altered, the whole system shifts. Neurotransmitters change. Receptors behave differently. Pathways that evolved to regulate pigment also ended up tied through deep biochemical crosstalk to how we experience the world. So the old idea of the fiery-tempered redhead, the sensitive redhead, the harder-to-numb redhead might not be entirely superstition. It might be a distorted echo of something real, something written in protein chains and neural circuits long before anyone told stories around a fire. But pain is only part of the picture. Move the spotlight from the brain to the skin, and another pattern appears. Pale skin and red hair are tightly linked to vitamin D. Darker skin protects against ultraviolet radiation, but it also blocks UV light from triggering vitamin D synthesis. In the bright equatorial sun, that's a good trade-off. Farther north, under cold gray skies, the math changes. Red hair and very light skin seem to have been one solution. With less eumelanin blocking the way, the skin of a light-skinned redhead can manufacture vitamin D from even weak sunlight. In places where the sun barely rises above the horizon in winter, that can be the difference between strong bones and rickets, between a healthy immune system and chronic disease. This is one reason many researchers think MC1R variants were strongly favored in certain northern environments. Not because red hair itself was magical, but because the package of traits it brought. Pale skin, altered UV sensitivity, maybe subtle shifts in metabolism helped people survive long, dark winters when vitamin D was scarce. But evolution always deals in trade-offs. The same lack of protective pigment that lets redheads make more vitamin D also leaves their skin more vulnerable to the sun's harsher side. Phenylalanine behaves differently under UV radiation. It seems to generate more reactive byproducts, little chemical sparks that can damage DNA. The result, on average, redheads have a higher risk of sunburn, a higher risk of certain skin cancers, especially in modern environments where people spend more time in direct sun than their medieval ancestors did under wool cloaks and thatched roofs. So, we face a puzzle. Why does a gene that increases cancer risk in sunlight persist at such high levels in some populations? Part of the answer lies in timing. Most cancers develop later in life, often after someone has already had children. Evolution cares most about reproductive success, not about what happens at 70. If a trait helps you survive childhood and reproduce, it can still be favored even if it has a hidden cost that shows up decades later. Another part of the answer might be that we're only seeing one side of MC1R's effects. The obvious visible side: hair, skin, sunburn. There's growing evidence that MC1R influences immune function and inflammation more broadly. Some variants may protect against certain infections. Others might modulate how the body responds to oxidative stress. A few studies even hint that the same pathways that increase skin cancer risk might paradoxically lower the risk of some internal cancers. In other words, the gene might not be purely good or bad. It might be a complex bundle of advantages and liabilities, with the balance shifting depending on climate, diet, lifespan, and culture. Then there's another claim that circles quietly through conversations and magazine articles: that redheads age differently. You've probably heard someone say redheads don't wrinkle as fast, or they keep a younger look longer. Is that true? The science is still thin, but there are hints. Some research suggests that certain MC1R variants may be associated with slower visible aging of the skin in specific areas of the face. Not immortality, not a fantasy of eternal youth. Just a subtle difference in how collagen breaks down, how pigment changes over time, how damage accumulates. But it's complicated. That same pale skin is more vulnerable to sun damage, which can accelerate aging if unprotected. Behavior matters. Culture matters. How often someone burned as a child, whether they avoided midday sun, whether they used any sort of protection long before sunscreen existed. So, when people say redheads look younger longer, they might be noticing a real trend in some individuals, or they might be responding to contrast. The same striking pigmentation that stands out in youth can keep standing out later in life. A 60-year-old with bright copper hair, even if it's faded or graying, doesn't blend in. Our brains read unusual as youthful simply because we see it less often. What we can say cautiously is this: MC1R doesn't stop at hair color. It touches multiple systems: skin, nerves, immune cells, maybe even how we age in ways we're only beginning to map. And that leads to a deeper question. If red hair comes with clear disadvantages in a sun-drenched world, higher skin cancer risk, more sun sensitivity, why didn't evolution simply erase it once humans spread south again? Why does it keep surfacing stubbornly like an ember that refuses to go out? One possibility is simple migration. The MC1R variants that became common in northern Europe may have ridden human movement into other regions, carried by traders, raiders, and wanderers into places where the original selective advantage was weaker but not yet entirely erased. Another possibility is sexual selection. In small populations, anything that stands out can become a magnet for attention. An unusual trait can spread not because it directly helps survival, but because it becomes desirable, symbolic, or culturally reinforced. If in some communities red hair became associated with power, mystery, or divine favor, then it was. It might have been chosen again and again, generation after generation, in a kind of feedback loop between biology and story. And then there's drift, the quiet role of genetic dice. In small, scattered groups, genes can rise and fall not because they are better or worse, but simply because of chance. A few influential individuals have many children. Those children inherit their hair, their eyes, their mutations. A local founder effect leaves its fingerprint on an entire region. The truth is likely a blend of all of these: harsh northern light, limited vitamin D, social preferences, random chance, and the deep, slow currents of human movement combining to keep this strange gene alive. As we lie here, centuries of superstition behind us and only a few decades of real data in front of us, we have to admit something humbling. We still don't fully understand MC1R. We can see its outlines. We can measure its effects in hospital wards, dermatology clinics, and research labs. We can trace its ancient lineage through Neanderthal bones and modern genomes. But the complete picture, how it shapes the brain, the immune system, the subtleties of mood, perception, and disease over a lifetime, is still coming into focus. New studies appear every year teasing connections between red hair and autoimmune conditions, between MC1R and how cells repair DNA, between pigment pathways and neurological traits we never thought to connect to hair color. Some of those findings will hold. Many will quietly fade as better data arrives. That's how science works: a slow sifting, a gentle winnowing toward the truth. What remains for now is a sense of wonder that a single gene once dismissed as a mere cosmetic curiosity may actually be a window into a much deeper story. How ancient humans adapted to changing skies. How our bodies balanced light and dark. How a risky, fragile trait could survive for hundreds of thousands of years. Because in just the right place, at just the right time, it made the difference between life and death. Somewhere inside, every redhead alive today, that story is still being written. Every freckle, every sunburn, every anesthetic dose adjusted in a quiet operating room, every sideways glance in a crowd when someone's copper hair catches the light. All of it is part of an ancient conversation between genes and environment that began long before the first myths of fiery hair and witchcraft, and will continue long after our current theories have been revised, refined, or replaced. We are only at the beginning of understanding this mysterious gene. And yet, even with all our machines and models and genomic maps, there is still room, maybe even a need for a little awe at the stubborn, shimmering persistence of that rarest flame you've probably heard the rumor passed around in headlines, shared in late-night conversations, whispered like a strange little prophecy, that redheads are going extinct, that this rare flame in human hair is about to flicker out forever. It sounds dramatic, tragic, almost poetic. But like so many stories we've told ourselves about red hair, it isn't what it seems. Because to understand the future of red hair, you have to understand how it survives at all. Not in the way a culture survives through memory and stories, but in the quiet, invisible way a gene survives. Generation after generation, hidden, waiting, patient. The MC1R gene, the one that turns hair into copper and fire, doesn't follow the rules our eyes expect. It doesn't shout, it whispers. It doesn't dominate, it hides. Geneticists call it recessive, which sounds like a weakness. It isn't. A dominant gene is like a torch in a dark room. One copy and everything changes. Brown eyes, dark hair, strong pigment. A recessive gene is like an ember buried in ash. You can carry it without knowing. It glows quietly, unseen until the right conditions line up and it flares into flame. Here's how it works. To show red hair, you need 2 copies of the red version of MC1R, one from each parent. If you only have one, the other copy usually overrides it. You might have slightly lighter skin, a touch more sensitivity to sunlight, maybe a hint of warmth in your hair, but no obvious red. Which means millions of people walking around the world right now are silent carriers of red hair. Their DNA holds the potential for copper, auburn, and gold. You'd never know by looking. That's the first problem with the extinction myth. It assumes that what we see is all there is. That if fewer people appear visibly red-haired in one generation, the gene must be disappearing. But genes don't work that way. As long as carriers exist, people with one copy of the red variant, the possibility of red hair remains. It can skip parents, skip grandparents, sleep through entire branches of a family tree, and then suddenly reappear in a child as if conjured out of nowhere. Every ginger baby born to 2 dark-haired parents feels like a magic trick. It isn't magic, it's probability. You can change how often red hair appears by changing how often carriers meet and have children together. Spread the carriers out across bigger populations and the visible flames might thin, shimmer, become rarer. But to make red hair truly vanish, you wouldn't just need fewer visible redheads. You would need almost every single carrier of those MC1R variants to stop having children everywhere for generations. Evolution doesn't usually erase traits like that unless they're lethal or severely disadvantageous. Red hair isn't either. In some environments, it may even have been an advantage, helping people make vitamin D in low sunlight or marking them as distinct within small communities, shaping who they married, who they followed, who they feared. So, no, red hair is not going extinct. It's doing what it has always done. Fading and brightening, hiding and reappearing, shaped by chance, migration, and love stories no one wrote down. But something has changed. For almost all of history, redheads had their fates decided for them by other people's stories, worshipped as sacred in one culture, hunted as witches in another, mocked, fetishized, feared. Today, for the first time, red hair is starting to write its own future. Look around the modern world and you'll find something that would have seemed impossible to a medieval villager or a Roman chronicler. Redhead festivals, entire gatherings dedicated to people with copper hair and freckled skin converging from dozens of countries like migrating sparks. In cities across Europe, in North America, in places where red hair used to be a target, it has become a celebration. Imagine the sight if you could drift above one of these festivals. Streets washed in shades of rust and flame, orange, strawberry blonde, deep mahogany red under the sun. Children with hair like bright pennies chasing one another. Older redheads who grew up being teased now surrounded by thousands of people who look like them. For generations, redheads were singled out. Now, for a few days each year, they're surrounded instead. Photographers call it a dream. Artists arrive to sketch. Scientists sometimes attend too, collecting cheek swabs and family stories, trying to trace the tangled roots of Missy 1R across continents. But beneath the surface, something quieter is happening. People are rewiring what red hair means to them. From curse to curiosity, from oddity to identity. Online movements grow up around the same idea. Social media pages and forums where redheads share childhood stories, sunburn strategies, favorite sunscreens, jokes about being daywalkers, conversations about stereotypes and representation. They trade ancestry results, debating whether their shade of red came from Irish roots, Scandinavian sailors, or something older and stranger. It isn't always comfortable. Stereotypes don't vanish overnight. Some of them have simply been repackaged as compliments. The idea of the fiery temper, the exotic seduction, the dangerous woman with rust-colored hair and a hidden agenda. But if you look at popular media over time, you can see the slow shift. For most of the last century, redheads in films and stories were often the same characters over and over. The villain with cold copper hair, the strange witch girl, the comic relief, the hot-headed youth, the temptress and the outcast. They were rarely allowed to be ordinary or complex. But as cameras and screens have multiplied, so have the ways red hair appears on them. Animated heroines with bright orange braids who are brave rather than cursed. Main characters whose hair is simply red because hair comes in red. Scientists, detectives, quiet introverts, kings, queens, side characters, background extras. The more redheads audiences see in different roles, the less anyone's stereotype can hold. Representation doesn't change the MC1R gene, but it can change whether a child grows up loving their reflection or hating it. And that matters because the future of any trait, cultural or genetic, isn't just about biology. It's about whether people carrying it feel at home in the world. Yet, there's another force shaping the future of red hair, one our ancestors never faced at this scale. Climate change, migration, the earth itself warming, patterns of rain and drought shifting, coastlines creeping inward, cities swelling and mixing populations that spent thousands of years apart. Red hair isn't just a color. It's tied to a set of traits. Fairer skin, different ways of processing pain and temperature, shifts in how the body handles sunlight. In the far north, where the sun is low and weak, those traits may have helped. In the blazing tropics, they can be a challenge. As climates change and people move, the environments that once favored high frequencies of red hair may change too. Northern regions may see stronger sun, harsher summers. People whose ancestors rarely had to worry about burning could find themselves doing what equatorial peoples have done for ages, covering up, seeking shade, learning new rhythms. At the same time, migration is dissolving old geographic boundaries. The Irish seafarers with MC1R variants have children with a partner from Lagos or Mumbai. The Scottish engineer meets a partner in Sao Paulo. The Norwegian student has a child with someone from Seoul. Each of those unions shuffles the genetic deck. Visible red hair might become rarer in some places, appear in surprising new ones in others. Freckles might show up in families that never saw them before. A ginger child might be born in a city where historically no one had hair that color at all. To someone standing in a single town across a single lifetime, it might feel like red hair is disappearing. To someone looking at the entire planet across many generations, it looks more like this. The flame is being carried outward, spread thinner maybe, but across a far wider canvas. Red hair has survived ice ages, plagues, wars, and crusades. It has been persecuted by superstition and recruited by empires. It has passed quietly through centuries when no one was writing its story down. It is unlikely that the thing to finally undo it will be a change in fashion or a century of hotter summers. If anything, the pressures of a changing planet could do what crises often do in human history: force new kinds of resilience, new kinds of mixing, new reasons to value difference, new ways of adapting that we can't yet predict. Because what is red hair really? When you strip away the legends, it's a single variation in a single gene, a tiny molecular decision. How much of one pigment, how little of another. And yet that decision has echoed through myths, wars, romances, and fears. It has left fingerprints in royal portraits and archaeological graves. It has colored the faces of revolutionaries and saints, of outcasts and rulers, of children who only wanted to go unnoticed. Red hair is a reminder of how much power there is in small differences, a reminder that rarity is not fragility, that something can be uncommon and still astonishingly persistent. When you see a redhead walking down a city street today, you're not just seeing a person with a certain hair color. You're seeing the survival of a genetic thread that may trace back through Neanderthal caves, Celtic battlegrounds, Viking ships, medieval courts, and quiet unknown villages where red hair lit up dark winter rooms like a tiny captured fire. Will there be more redheads in the future? Fewer different patterns across the globe? We can model probabilities, trace carrier frequencies, guess at how climate and culture will interact. But the truth is simpler and stranger. Red hair will almost certainly endure, not as a steady, predictable flame, but as a wandering spark, sometimes bright and clustered, sometimes scattered and rare, always capable of being rekindled wherever two carriers quietly meet. Like so many parts of human diversity, it doesn't have a single story or a fixed destiny. It has possibilities. It has memory written in molecules. It has time. And as long as humans keep crossing paths, falling in love, and passing their genes forward into futures they'll never see, the MC1R ember will travel with them, invisible in most, brilliant in a few. A small, stubborn, beautiful reminder that our species was never meant to be uniform. We were meant to be a spectrum of colors, of histories, of quiet, mysterious flames that refuse to go out. So now when you picture red hair, you're not just seeing a color anymore. You're seeing a timeline, a fuse burning across nearly 1,000,000 years. From Neanderthal hunters standing at the mouth of an ice age cave, amber firelight catching strands of copper in their hair, to medieval queens and warlords steering the fate of empires, to a scientist in a modern genetics lab staring at the tiny MC1R gene glowing on a computer screen. All of them linked by the same improbable spark. Imagine a gene so rare it appears in less than 2% of all humanity. A genetic flame that flickers in the DNA of fewer than 140 million people scattered across an entire planet of 8 billion. Now imagine that this tiny sliver of genetic code has sparked witch hunts, toppled kingdoms, inspired ancient legends, and marked people for persecution across thousands of years. This is the story of red hair, and everything you think you know about it is probably wrong. We've been told red hair is a simple Celtic trait. Scottish, Irish, maybe some Vikings thrown in. A quirky genetic mutation that makes people stand out at the beach. Folklore and fair skin, lucky charms and leprechauns. But what if I told you that red hair might be far, far older than we ever imagined? That it could have flickered to life not in the misty highlands of Scotland, but in the dark caves of Ice Age Europe, carried by people who weren't even entirely human? What if the flame-haired people in ancient Egyptian texts, in Greek mythology, in Roman histories weren't myths at all, but fragments of a genetic story we're only now beginning to understand? Tonight, we're going to follow that story from Neanderthal caves 50,000 years ago to the genetic laboratories of today. From the warrior queens who wore their red hair like war paint to the condemned women who burned at the stake because of it. From the palaces where it marked royalty to the streets where it marked you for death. And here's the thing that makes this story so haunting. Red hair is vanishing. That 2% is shrinking. Some scientists say it could fade from the human population entirely within a few centuries. A genetic flame that survived ice ages, migrations, plagues, and persecution, finally flickering out in the modern world, unless something changes. But before we dive into ancient caves and forgotten civilizations, before we talk about the witch trials and the warriors and the cutting-edge science that's rewriting everything, I want to know something. Where are you right now? What time is it where you're watching this? Are you drifting off to sleep in Sydney, having breakfast in Berlin, winding down after work in Seattle? Drop a comment and let me know. I actually read them, and there's something kind of beautiful about knowing we're all here together, scattered across time zones, about to go on this journey into history's strangest genetic mystery. Because that's what this is, a mystery. One that involves secrets buried for thousands of years in the DNA we carry, in the bones we're still excavating, in the myths we thought were just stories. See, red hair isn't just about genetics. It never was. It's about identity and persecution. About what it meant to look different in ancient Egypt, in medieval Europe, in practically every civilization that ever encountered it. The MC1R gene, the tiny slip of genetic code responsible for red hair, has been connected to everything from supernatural powers to moral corruption. People with red hair have been worshipped as gods and burned as demons, sometimes in the same century, sometimes in the same country. And the science we're only now understanding suggests the story goes back much further than anyone suspected, to a time when multiple species of humans walked the earth, when Neanderthals and Homo sapiens met, mingled, and possibly shared more than just territory, when the first redhead children might have been born from unions were only beginning to map genetically. Ancient writers described red-haired people in places they shouldn't have been. Red-haired mummies in China, thousands of miles from Celtic lands, red-haired pharaohs in Egypt, red-haired warriors in accounts from Greece, Rome, North Africa. For centuries, historians dismissed these as errors, exaggerations, or myths. They weren't myths. We're going to trace that crimson thread through history. We're going to see how red hair became tangled up with magic and witchcraft, with royalty and revolution, with fear and fascination. We're going to explore why the same gene that might have helped our ancestors survive in the dim light of Ice Age Europe became a death sentence during the Inquisition. And we're going to ask the question that geneticists are only now beginning to seriously consider. What if red hair was never just one thing? What if it appeared multiple times in multiple populations through multiple genetic pathways we're only starting to map? The flame that history tried to extinguish refuses to go out quietly. And tonight, we're going to find out why. This is the story of red hair. The real story. The one they never told you. Let's begin. Let's talk about something that doesn't make sense. A mutation. A single genetic variation that creates one of the most recognizable traits in human history. Red hair, not brown with reddish tones, not orange, true red, the kind that looks like someone bottled fire and poured it onto a human head. It all comes down to a gene called MC1R, melanoin 1 receptor. Sounds technical because it is. This gene sits on chromosome 16, minding its own business in the vast majority of humanity, producing eumelanin, the dark brown or black pigment that colors most people's hair and skin. But in about 1 to 2% of the global population, this gene has a different plan entirely. A mutation, not a catastrophic one. Not the kind that causes disease or dysfunction. Just a small change. A few letters in the genetic code swapped out for different ones. But those few letters make all the difference. Instead of producing eumelanin efficiently, the mutated MC1R gene produces phamelanin, red and yellow pigments. And when you get a lot of phamelanin and very little eumelanin, you get red hair. Simple, right? Except nothing about this is simple. Because this mutation doesn't just create red hair and call it a day. It comes with a whole package of traits, a bundle of characteristics that make redheads fundamentally different from other people in ways we're only beginning to understand. First, there's the skin. Pale, often so pale it's almost translucent. This isn't coincidence. The same MC1R mutation that produces red hair also dramatically reduces the skin's ability to produce dark pigment. Then come the freckles. Those tiny spots of concentrated melanin that appear like constellations across faces, shoulders, arms. They're not random. They're the skin's desperate attempt to protect itself from ultraviolet radiation when it can't produce enough dark pigment uniformly. And here's where it gets interesting. Redheads sunburn faster than any other group of people, significantly faster. While someone with dark hair might get 30 to 40 minutes in direct sunlight before burning, a redhead might have 10, maybe less. Their skin simply cannot protect itself the way other skin types can. They produce vitamin D more efficiently in low-light conditions, which is an advantage in northern climates, but under direct sun. They're vulnerable in ways that should have been eliminated by natural selection long ago. But wait, there's more. Because the MC1R gene doesn't just affect pigmentation. It influences the body's pain response. Multiple studies have shown that redheads have different pain thresholds than other people. They're more sensitive to thermal pain, hot, and cold. They require more anesthesia during surgery, sometimes 20% more, because their bodies process painkillers differently. They're more resistant to local anesthetics, like the ones dentists use. They even respond differently to certain pain medications, finding some completely ineffective, while others work better than they do for the rest of humanity. The MC1R gene is connected to pain receptors in ways scientists are still trying to understand. It's not just about hair color. It's about fundamental differences in how the nervous system functions, how the body experiences and processes physical sensation. This is deep stuff, evolutionary stuff, the kind of genetic variation that shouldn't exist unless it's serving some purpose we haven't fully grasped. Now, here's the part that makes genetic students everywhere groan. The MC1R mutation is recessive. Both copies of the gene, one from each parent, need to carry the mutation for someone to have red hair. If you get one normal copy and one mutated copy, you'll probably have brown or dark blonde hair. You're a carrier, but you don't express the trait. This means two brown-haired parents who both carry the recessive gene can have a red-haired child, which has caused more than a few awkward conversations throughout history. But it also means something else, something profound. For red hair to persist in a population, the gene has to be passed down through generations of people who don't even express it. Carriers. People who have no idea they're carrying this genetic flame until suddenly their child is born with hair the color of autumn leaves. The mathematics of recessive inheritance are brutal. If both parents carry one copy of the red hair gene, each child has a 25% chance of being a redhead, a 50% chance of being a carrier, and 25% chance of not carrying the gene at all. For the trait to remain even moderately common in a population, it needs to either provide some survival advantage or be actively selected for through mate choice or something else entirely, something we haven't considered. Because here's the question that should keep evolutionary biologists awake at night. Why does red hair exist at all? Forget why it persists. Why did this mutation survive its first generation? A trait that makes you sunburn in minutes, that makes your pain receptors fire differently, that marks you as visibly distinct from everyone around you in the harsh world of prehistoric humanity, where survival was never guaranteed and standing out could be dangerous. What possible advantage could red hair provide? The standard explanation goes like this. Red hair evolved in northern climates where sunlight was scarce. The pale skin that comes with the MC1R mutation helps produce vitamin D in low-light conditions. Makes sense, right? Except vitamin D deficiency, while serious, typically does not kill you before reproductive age. Sunburn and skin cancer, however, can, and if early redheads were living anywhere near the equator, even briefly, the disadvantages would have far outweighed the benefits. Some researchers suggest sexual selection. Maybe people found red hair attractive, so the gene spread through mate preference rather than survival advantage. Possible. But sexual selection usually requires some underlying fitness indicator. Bright plumage in birds signals genetic health. What would red hair signal except vulnerability to the sun? Others point to the pain threshold differences. Maybe altered pain response provided some advantage we don't understand. Greater resistance to certain types of injury, enhanced awareness of environmental dangers. We're grasping at straws here because the honest answer is, we don't really know. But what if we've been asking the wrong question? What if red hair didn't evolve in isolation as a response to one environment or selective pressure? What if it's older than we think? Much older. What if the story of red hair doesn't begin with Celtic tribes in Scotland or Viking raiders in Scandinavia? What if it begins somewhere else entirely, somewhere unexpected? The thing about genetic mutations is they leave traces, signatures in the DNA that can be followed backward through time like breadcrumbs through a forest. And when researchers started following the red hair mutation backward, tracing its origins through population genetics and ancient DNA analysis, they found something nobody expected. The mutation is old, really old, older than modern human populations in Northern Europe, older than the migration patterns we usually associate with red hair. And it appears in places it shouldn't, in genetic lineages that don't make sense according to the standard story. The MC1R mutation shows up in ancient populations that had no business being pale-skinned and sun-sensitive. It appears in contexts that suggest multiple origins or a single very ancient origin that predates the migrations we thought brought red hair to Europe. The genetic evidence is pointing somewhere else, somewhere further back, to a time when humanity looked very different than it does now, to a world populated not just by our direct ancestors, but by other human species, relatives who shared our genus but not our exact evolutionary path, species who might have carried their own version of the red hair gene, species who might have passed it to us through interbreeding thousands of years ago, species whose DNA still lurks in modern human genomes, including in that tiny segment of chromosome 16 that determines whether your hair catches fire in the sunlight. We're about to go backward, way backward, to a time when humans weren't the only game in town. When our ancestors shared the world with other kinds of people who looked similar but weren't quite the same. People who might have been the first redheads. People whose story has been hidden in our DNA this entire time, waiting for us to develop the technology to read it. The story of red hair begins not in the mists of Celtic Scotland, but in the depths of the last ice age, with a people we've drastically underestimated, a people who might have given us more than we ever imagined, including nature's rarest flame. Now, here's where this story takes a turn that nobody saw coming. A turn that changes everything we thought we knew about red hair and where it came from. October 2007, a team of geneticists at the Max Planck Institute in Leipzig, Germany, published a paper that sent shockwaves through the scientific community. They'd been working on something that seemed impossible just a decade earlier, extracting and sequencing DNA from Neanderthal bones that were over 40,000 years old. And buried in that ancient genetic code, they found something extraordinary. Neanderthals had red hair, not all of them probably, but some, maybe many. The evidence was right there in their DNA. A variant of the MC1R gene that would have produced the same effect we see in modern redheads. Pale skin, reduced melanin production, and that distinctive flame-colored hair. The discovery was accidental. The researchers weren't looking for hair color genes specifically. They were trying to understand Neanderthal biology in general, sequencing whatever genetic material they could recover from ancient bones. But when they analyzed the MC1R gene, the one responsible for melanin production, they found something they never expected. A mutation. A change in the DNA sequence that disrupted normal pigment production in exactly the way that creates red hair in modern humans. But here's what made it really interesting. It wasn't the same mutation that causes red hair in humans today. It was different. A separate genetic change in the same gene producing the same result through a completely different mechanism. This wasn't inheritance. This was convergent evolution. Two different species separated by hundreds of thousands of years of evolution independently developing the same trait. Or was it? Because that's where the debate begins. That's where the questions start multiplying faster than anyone can answer them. Some scientists looked at the evidence and said, "See, Neanderthals had red hair independently when they interbred with modern humans later. Maybe some of that Neanderthal red hair DNA got mixed into our gene pool." Others argued the opposite. The mutations are different. Modern red hair has nothing to do with Neanderthals. This is just parallel evolution, similar solutions to similar problems. But the timing makes you wonder. Remember those three human species we talked about? Modern humans, Neanderthals, and Denisovans, all descended from the same bottleneck survivors. They were still genetically close enough to interbreed when their populations met, and meet they did, round 60,000 years ago, when modern humans finally left Africa and pushed into Europe and Asia. They encountered Neanderthals who'd been living there for hundreds of thousands of years. And they didn't just encounter them. They had children with them. We know this because every person of European, Asian, or Native American descent carries Neanderthal DNA. Between 1 and 4% of the genome in non-African populations comes from Neanderthals, genes that were shaped by 300,000 years of adaptation to Ice Age Europe, now sitting in the chromosomes of billions of modern humans. Genes for immune system function, for skin thickness, for temperature regulation. Survival genes tested by millennia of brutal natural selection and passed down through countless generations of interbreeding. So the question becomes, could red hair be one of those inherited traits? Could the MC1R variants we see in modern populations actually trace back at least partially to those ancient encounters in the caves and valleys of Ice Age Europe? The honest answer is we don't know for certain. The genetic evidence is complicated. Most modern red hair mutations appear to have arisen independently in Homo sapiens populations, but there are some variants, some specific changes in the MC1R gene, where the origin is less clear, where the possibility of Neanderthal ancestry can't be completely ruled out. And when you think about the environment they were living in, it starts to make sense why both species might have evolved red hair. Picture Ice Age Europe. This isn't the Europe you know today, with its moderate climate and gentle seasons. This is a world locked in glaciation, a world where ice sheets a mile thick cover everything north of modern Germany, where winters last 8–10 months and summer is just a brief respite before the cold returns. In this world, sunlight is scarce, not just in winter when the days are short and the sun barely rises above the horizon, but year-round. The ice reflects light back into space. Clouds and storms dominate the weather patterns. Even on clear days, the angle of the sun at high latitudes means less UV radiation reaches the ground. For populations living in these conditions, dark skin becomes a disadvantage. Melanin, that protective pigment that shields against intense sunlight in Africa, now blocks the weak UV rays needed to produce vitamin D. Dark-skinned individuals in Ice Age Europe would have faced severe vitamin D deficiency, rickets, bone deformities, weakened immune systems. Natural selection would favor any genetic change that lightened skin that allowed more UV penetration. The MC1R mutation does exactly that. It reduces melanin production across the board, lightening skin and making hair red or blonde. In the perpetual twilight of Ice Age Europe, this would have been a survival advantage. Those pale-skinned, red-haired individuals would have been healthier, stronger, more likely to survive and reproduce. So, Neanderthals adapted. Over tens of thousands of years, as they pushed deeper into Europe's frozen north, natural selection favored lighter pigmentation. Some populations developed the mutations that created red hair and pale skin. Others might have developed different variants that produced blonde hair or simply lighter brown. We don't know the full picture because we only have DNA from a handful of Neanderthal specimens, but what we do know suggests that by 100,000 years ago, some Neanderthal populations looked very different from their African ancestors. Paler, lighter-haired, adapted to a world of ice and darkness. Then modern humans arrived, and they faced the exact same environmental pressures, the same weak sunlight, the same need for vitamin D, the same selective advantage for reduced melanin production. Some of them already carried their own MC1R mutations, variants that had arisen independently in African populations. Others developed new mutations after arriving in Europe, genetic changes that happened to provide exactly the right adaptation at exactly the right time. And some maybe received the gift of pale skin and red hair through a different route entirely. Through children born of Neanderthal and Homo sapiens parents, through hybrid populations that carried genes from both species, through countless small moments of genetic exchange that happened over thousands of years of coexistence, because that's the part of the story that often gets lost. The interbreeding between modern humans and Neanderthals wasn't a single event. It wasn't one dramatic encounter and done. It was thousands of years of overlap of populations living in adjacent territories, occasionally interacting, sometimes having children together. From about 60,000 to 40,000 years ago, modern humans and Neanderthals occupied the same landscapes across Europe and Western Asia, long enough for extensive genetic exchange, long enough that the boundaries between the species began to blur. Some researchers now argue that Neanderthals didn't really go extinct. They were absorbed, outbred by the larger modern human population until their distinctive features disappeared into the general gene pool. If that's true, then every person with Neanderthal ancestry, which is most people outside Africa, carries a ghost of that ancient species in their cells. And red-haired people, people with that distinctive MC1R phenotype, might carry a particularly vivid ghost, not because modern red hair necessarily comes from Neanderthals. The genetics are too complicated to say that definitively, but because red hair represents the same adaptation that Neanderthals developed. The same solution to the same problem, the same genetic strategy for survival in a world of ice and darkness. When you see a red head, you're seeing an echo of Ice Age Europe, a trait that exists because 100,000 years ago in the frozen valleys and wind-swept tundras of a world very different from ours, pale skin and flame-cold hair meant the difference between life and death. Whether that trait came from Neanderthals, arose independently in modern humans, or represents some complex mixture of both, it's a survivor's trait, a reminder that we carry adaptations shaped by environments we can barely imagine. And here's the really tantalizing part, the really profound question that keeps researchers up at night. If we carry Neanderthal genes for physical traits, what else might we have inherited? Neanderthals had larger brains than modern humans. They buried their dead with ceremony. They created art, played music, cared for their sick and elderly. They were cognitively sophisticated, culturally complex, fully human in every way that matters. When we interbred with our ancestors, what cognitive traits, what personality characteristics, what ways of thinking might have crossed the species boundary? Could some of the diversity in human psychology, the different ways people process information and interact with the world, trace back to Neanderthal ancestry? Are we not just physically but mentally a hybrid species carrying the cognitive legacy of multiple human lineages? We don't know. But every new discovery, every new analysis of ancient DNA suggests the picture is more complicated than we thought. That the neat categories we created, modern human versus Neanderthal, might not reflect the messy reality of how our species actually formed. That we are all of us products of mixture and exchange and survival strategies tested across hundreds of thousands of years. And redheads with their rare genetic variant and their distinctive appearance might be the most visible reminder of that deep tangled history. Walking evidence that humanity's story involves more than one species, more than one evolutionary path, that we are the sum of everyone who came before. The inheritors of every survival strategy, every adaptation, every desperate genetic gamble that paid off in the frozen world of our ancestors. The flame-haired among us aren't just rare, they're ancient. Older than history, older than civilization, older than agriculture or writing, or any of the things we think of as fundamentally human. They're a bridge to a world of ice and megafauna and multiple human species competing for survival in the harshest environments Earth had to offer. And somehow, impossibly, wonderfully, that ancient trait survived, carried forward through countless generations, preserved by chance and selection, and the simple fact that in certain places, under certain conditions, it helped people live long enough to have children. But the story doesn't end in Ice Age Europe, not even close. Because red hair spread, changed, became something more than just a survival adaptation. It became tangled up with culture and mythology and fear. And that's where things get really interesting. Picture this. You're standing in the Cairo Museum in 1881. The air is thick with dust and the smell of ancient linen. In front of you lies the mummy of Ramesses II, pharaoh of Egypt, ruler of the most powerful empire on earth 3,200 years ago. And as the linen wrappings are carefully removed, something impossible appears. Red hair, not the faded auburn of oxidized melanin, not the henna dye that Egyptian nobles sometimes used, but genuine natural red hair, bright, unmistakable. and completely unexpected on the mummy of a man whose people were supposed to be dark-haired and dark-skinned. The archaeologists were baffled. Modern analysis would later confirm what their eyes told them. Memes too carried the MC1 Rene variant. The pharaoh who enslaved the Israelites, who fought the Hittites at Kadesh, who built Abu Simbel and ruled Egypt for 66 years, was a natural red head, but he wasn't alone. As more Egyptian mummies were examined, more red hair appeared. Not everywhere, not in most burials, but often enough to create a pattern. Often enough to suggest that red hair wasn't just some genetic fluke in ancient Egypt. It was present, recognized, maybe even significant. Ancient Egyptian texts describe people with, quote, zero. Some tomb paintings show figures with distinctly reddish hair, though whether this was literal or symbolic remains debated. What's clear is that Egyptians noticed red hair. They had words for it. They recorded it. And they weren't the only ones. Because if you travel 4,000 meters east from Egypt into the heart of the Taklamakan Desert in western China, you'll find something even more impossible. The Tarim mummies. Hundreds of naturally preserved bodies buried in the dry desert sand between 2,000 and 4,000 years ago. Bodies that should have belonged to ancient Chinese people, or at least to populations from somewhere in Asia. Except they didn't. When archaeologists first discovered these mummies in the early 1900s, they couldn't believe what they were seeing. Caucasian features, European facial structures, clothing that looked Celtic or Germanic in style, and red hair, lots of red hair. The most famous is the beauty of Lulon, a woman buried around 1800 BCE. She has light brown to reddish hair, Caucasian features, and was buried wearing felt clothing decorated in a style that would look at home in Bronze Age Europe. Next to her grave, archaeologists found wheat, which was not native to the region. She wasn't Chinese. She wasn't from anywhere nearby. Yet there she was, buried in the heart of China 2,000 years before Marco Polo supposedly opened the Silk Road. Then there's Zas, quote, too, buried around 1000 BCE. 6 feet tall, reddish-brown hair, elaborate woven clothing and tartans that look remarkably Scottish. Buried with his wife and child, all showing similar Caucasian features. Genetic analysis of these mummies has only deepened the mystery. They weren't ancestors of modern Chinese populations. Their DNA shows closer relationships to populations from the Caucasus, Central Asia, and even Western Europe. These weren't traders who died passing through. These were communities, settlements, people who lived and died in Western China for thousands of years before they vanished from history. And many of them had red hair. How did they get there? Why were they there? The standard narrative of human migration doesn't have easy answers. We're taught the Caucasian population stayed in Europe and the Middle East until relatively recent times. That Central Asia was populated by Mongoloid peoples moving west, not Caucasoid peoples moving east. But the mummies tell a different story. They suggest that during the Bronze Age, maybe even earlier, populations carrying European genetic traits, including the MC1R variants for red hair, had spread all the way to China. They were building communities, developing sophisticated textile technologies, farming wheat in the desert. Some researchers think they might have been among the first to domesticate horses, spreading both the animals and the riding technology that would eventually revolutionize warfare across Eurasia. Others suggest they were crucial in establishing the trade routes that would later become the Silk Road, creating the networks that connected East and West. But then they disappeared. By the time Chinese historical records begin in earnest, these red-headed people are gone. Absorbed into other populations or wiped out by some disaster we can't identify. Only their mummies remain, perfectly preserved in the dry desert air, waiting to confuse archaeologists millennia later. The pattern appears again in North Africa among the Berbers. Travel to the Atlas Mountains of Morocco or Algeria today, and you'll find something unexpected. Berber populations with blue or green eyes, light skin, and yes, red hair. Not everywhere, not in most families, but common enough that it's clearly part of their genetic heritage. The Berbers themselves have a legend about this. Stories of red-haired ancestors who came from the sea or descended from the mountains in ancient times. Modern genetic studies show they carry European genetic markers at surprisingly high frequencies, including MC1R variants. But here's where it gets really interesting. The Berbers didn't just acquire these genes through recent mixing with European colonizers. The genetic signatures are old, really old. Some researchers think they date back to the Neolithic period, 5,000 to 7,000 years ago, suggesting ancient migrations from Europe into North Africa that left no written record but mark the DNA of millions. The ancient Greeks and Romans noticed red hair too, but their reactions were complicated. Greek texts describe red-haired people, usually foreigners or barbarians from the north. Thryans, Ceans, Celts, people from beyond the borders of the civilized world. Some Greek writers seemed fascinated by red hair. Others saw it as a mark of barbarism, connecting it with wild, univolized peoples. The historian Tacitus described Germanic tribes with fierce blue eyes and red hair, suggesting these features were markers of their savage nature. But Romans also fetishize red hair. Redhead slaves, particularly women from Celtic regions, commanded premium prices in Roman markets. Some wealthy Roman women dyed their hair red using imported dyes, trying to emulate the exotic appearance of northern captives. The poet Martial wrote about the fashion for red wigs made from the hair of Germanic slaves. Roman society was simultaneously repulsed by and attracted to the red-headed peoples they encountered and conquered. What we're seeing in all these ancient societies is the same pattern. Red hair appearing in unexpected places far from where we think it should be. Populations carrying the MC1R variants showing up in Egypt, in China, in North Africa, across the ancient Mediterranean world. Traditional models of human migration do not fully explain this distribution. If red hair evolved primarily in Northern Europe as a response to low UV radiation, why does it keep appearing in the archaeological and genetic record of places that never had that selective pressure? Maybe our models are incomplete. Maybe the MC1R variants are older and more widely distributed than we thought. Maybe the bottleneck survivors who expanded out of Africa 800,000 years ago carried multiple variants with them. Variants that persisted in small frequencies across many populations. Or maybe red hair spread through ancient migrations we've forgotten about. Bronze Age peoples moving east into China. Neolithic populations crossing from Europe into North Africa. Seafaring cultures trading genes, along with goods around the ancient Mediterranean. The truth is probably some combination of all these factors. Ancient human populations were far more mobile and interconnected than we often imagine. The genetic evidence keeps showing us that people moved, mixed, and migrated in ways that leave traces in our DNA, but often left no written records. Those red-haired Egyptian mummies, those Caucasian bobbies in the Chinese desert, those Berber populations with European genetic markers, they're all telling us the same thing. The ancient world was connected in ways we're only beginning to understand, and red hair, that rarest of human traits, was there too, appearing in royal Egyptian tombs, preserved in Chinese mummies, documented in Greek and Roman texts, surviving in isolated populations across continents. It wasn't just a northern European phenomenon. It was part of the story of ancient humanity. A genetic signature that traveled with populations we've forgotten, appeared in cultures we barely understand, and survived in bloodlines that connect the modern world to ancestors whose names we'll never know. But the story of these ancient redheads raises a question. If red hair was present across the ancient world, why did it become so concentrated in certain regions? Why does Celtic and Germanic populations carry it at such high frequencies while it virtually disappeared from places like Egypt and China? The answer would shape not just the genetics of red hair, but the entire cultural meaning it would carry into the medieval period and beyond. Now we come to the part of the story where red hair stops being just a genetic curiosity and becomes something else entirely. Something powerful, something feared, something that would shape the destiny of entire civilizations. Picture yourself as a Roman soldier stationed in Gaul, modern-day France around 58 BCE. You've heard the stories. Every legionnaire has tales of the warriors who live beyond the edges of civilization in the forests and highlands, where Roman order is not yet reached. You've been told they're barbarians, univolized tribes who paint themselves blue and worship strange gods in sacred groves. But nothing prepares you for the first time you see them charging across a battlefield. Their hair is on fire. or at least that's what your brain tells you in that first terrifying moment. Streams of red and gold flowing behind warriors who seem taller than any men you've ever seen. They're screaming in a language that sounds like thunder, wielding massive swords that no Roman soldier could lift with one hand. Some of them are naked except for torques of twisted gold around their necks. Their bodies are covered in swirling blue patterns that seem to move as they run. And that hair, that impossible flame-cold hair that catches the sunlight like wildfire spreading across a field. The Romans were the greatest military power on earth, but they were genuinely terrified of the Celts. And the historical sources make it clear that the red hair wasn't just noticed, it was central to the terror these warriors inspired. Julius Caesar himself wrote about them. He described the Gauls as having bodies, quote, 4 with hair that was, quote, 5. They weren't just accepting their red hair, they were enhancing it, bleaching it lighter, making it stand up in wild spikes. War paint applied to their hair and bodies before battle. This wasn't vanity. This was psychological warfare of the most sophisticated kind. Other Roman writers were even more specific. Diocletian described the Britons as, quote, 6. Tacitus, writing about the Germanic tribes, noted that red hair was common among northern peoples, setting them apart from the darker-haired Mediterranean populations. But here's what makes this really interesting. The Celts weren't one unified people. There were hundreds of different tribes spread across Europe. From the Iberian Peninsula to the Balkans, from the British Isles to Asia Minor. Yet, wherever Romans encountered them, they consistently described the same features: great size, fierce independence, and that distinctive red or reddish-blonde hair that seemed to mark them as different from everyone else. So, why were the Celtic regions such hotspots for red hair? Why did Ireland and Scotland become the places where this trait survived and thrived more than anywhere else on Earth? The answer takes us back to geography, genetics, and a very specific kind of isolation. The Celtic peoples who ended up in Ireland and Scotland weren't running toward islands. They were being pushed there. As waves of migration swept across Europe over thousands of years, different populations displaced earlier ones, driving them westward and northward. The Atlantic Ocean was the end of the line. Once you reached Ireland or the Highlands of Scotland, there was nowhere left to go. This created what population geneticists call a refuge population. Groups of people isolated not by choice but by circumstance, cut off from the larger genetic mixing happening on the continent. In these isolated populations, rare genetic traits can become common through what's called the founder effect. Imagine a ship carrying 100 people lands on an empty island. By pure chance, 10 of them carry the gene for red hair. On the mainland where millions of people live, 10 redheads wouldn't make much difference. But on that island, they represent 10% of the founding population. Their children marry other islanders. And because the gene pool is so small, the red hair gene gets passed along at much higher frequencies than it would in a larger population. Now, scale that up over thousands of years, and you start to understand how Ireland became the red hair capital of the world. Somewhere between 10 and 15% of the Irish population carries the phenotype today. In some regions of Scotland, it's even higher. Compare that to less than 2% globally. But the Celts didn't just preserve red hair. They transformed it into something mystical. The Druids were the priestly class of Celtic society, and the fragmentary accounts we have of their beliefs suggest red hair held special significance. The Druids believed in a connection between physical appearance and spiritual power. Red hair, rare and striking, was seen as a mark of otherworldly connection. Some scholars think red-haired individuals were more likely to be selected for Druidic training. The reasoning was that anything unusual or different was closer to the boundary between the human world and the realm of gods and spirits. Red hair was a physical manifestation of that liminal quality, a sign that the person existed between worlds. We have to be careful here. Our sources on Druidic practices are limited and often filtered through Roman observers who had their own biases and agendas. The Romans systematically destroyed Celtic oral traditions, burning sacred groves and executing Druids wherever they found them. What survived was fragmentary, preserved in later Irish and Welsh literature that had already been influenced by Christianity. But patterns emerge. In Irish mythology, many of the most powerful figures have red or golden hair. The goddess Bridge, associated with fire, poetry, and healing, is often described as having red golden hair. Lugh, the god of light and craftsmanship, is similarly depicted. The legendary hero Cuchulainn was said to have hair with 3 colors: dark at the roots, red in the middle, and golden at the tips. This wasn't accidental. The mythological tradition was preserving something real about how Celtic peoples viewed red hair as connected to power, divinity, and transformation. Then there's Boudica. Around 60 CE, a woman with red hair nearly destroyed Roman Britain. Boudica was queen of the Aini, a Celtic tribe in eastern Britain. When her husband died, the Romans decided to annex territory. They fagged Boudica publicly and assaulted her daughter. It was meant to humiliate, to break resistance, to demonstrate Roman supremacy over these barbarian people. It had the opposite effect. Boudica raised an army. Dio cases described her appearance in terms meant to terrify Roman readers. She was huge of frame, terrifying of aspect, and with a harsh voice. A great mass of bright red hair fell to her knees. Notice what he emphasizes. Not just her size or her anger, but specifically that red hair. In Roman minds, it marked her as quintessentially barbarian, fundamentally other, impossible to civilize or control. Boudica's rebellion nearly succeeded. Her forces destroyed Llandinium, modern London, and 2 other Roman settlements, killing an estimated 70,000 people. The Roman governor, Gaius Suetonius Paulinus, had to abandon his campaign in Wales and rush back with his legions to prevent the complete loss of Britain. The rebellion was eventually crushed, and Boudica probably died by poison or suicide rather than face capture. But she became a symbol, a redhead Celtic queen who chose death over submission to Rome. Her story would echo through the centuries. Every time the Celts fought against conquest, every time they resisted assimilation, the image of the flame-haired warrior queen stood as proof that some things couldn't be conquered. But why did red hair become so symbolically important, specifically among the Celtic peoples? Other populations had red heads. We know Neanderthals carried variants of the MC1R gene. Archaeological evidence suggests red hair appeared in various ancient populations across Eurasia. The difference was cultural reinforcement. The Celts didn't just tolerate red hair, they celebrated it. They enhanced it artificially when they didn't have it naturally. They will into their mythology and their understanding of spiritual power. And perhaps most importantly, they survived in sufficient isolation to maintain relatively high frequencies of the trait, even as other populations mixed and diluted it. Ireland was particularly important in this process. Unlike Britain, Ireland was never conquered by Rome. The legions never crossed the Irish Sea in force. This meant Celtic culture in Ireland remained relatively intact, evolving on its own terms rather than being absorbed into the Roman system. When Christianity arrived in Ireland in the 5th century CE, it didn't replace Celtic culture so much as blend with it. Irish monks preserved ancient legends and genealogies, writing them down in manuscripts that survived when oral traditions elsewhere were lost. These manuscripts give us our clearest window into how pre-Christian Celts viewed themselves in their world. And red hair shows up again and again in genealogies of noble families, in descriptions of heroes and saints, in poetry celebrating beauty and valor. It's woven through Irish literature like a scarlet thread, marking those who possessed it as special, noteworthy, connected to older powers. The geography helped too. Ireland's position on the western edge of Europe meant it became a terminal point for genetic flow. Populations arrived and stayed, contributing their genes to the pool, but rarely leaving. Over generations, this created a genetic profile distinct from continental Europe, one where traits like red hair were preserved at unusually high frequencies. Scotland followed a similar pattern. The Highlands in particular were extremely isolated, with small communities separated by difficult terrain. These pockets of population could maintain distinctive genetic profiles for generations, even centuries, with limited mixing from outside groups. By the early medieval period, red hair had become almost synonymous with Celtic identity in the popular imagination. Whether or not every Celt actually had red hair, the association was fixed. The flame-haired warrior, the red-haired druid, the fiery Celtic woman who could not be tamed. These weren't just stereotypes. They were cultural memories of a people who had made red hair central to their identity. But the story was about to take a darker turn. Because as the Roman Empire fell and new powers rose across Europe, that distinctive red hair would transform from a mark of honor into something far more dangerous, a target. Forget everything Hollywood told you about Vikings. Forget the image of towering blonde warriors with braided beards standing at the prow of long ships. That's not wrong exactly, but it's dramatically incomplete because the genetic evidence tells a very different story. A story written in red. The Vikings weren't a genetically homogeneous population. They weren't all descended from some mythical Nordic prototype with golden hair and ice-blue eyes. They were a diverse collection of peoples spread across Scandinavia, each region with its own genetic makeup, its own characteristics, and a significant number of them, perhaps more than we've ever acknowledged, carried the MC1R variants that produced red hair. Recent genetic studies of Viking burial sites across Scandinavia have revealed something fascinating. Analysis of ancient DNA from hundreds of Viking-age individuals shows MC1R variants appearing in frequencies much higher than previously assumed. Not the majority, but common enough that every Viking community would have had its share of red-haired warriors, traders, explorers, and settlers. Think about what this means. When we picture the Viking expansion across Europe, we need to imagine long ships crewed not just by blonde Scandinavians, but by red-haired raiders carrying those rare genetic variants into populations that had never seen them before, or had only encountered them rarely through earlier Celtic connections. Around 800 AD, something changed in Scandinavia. Population pressure, climate shifts, political consolidation. The exact causes are still debated, but the result was undeniable. The North began expanding outward in every direction at once, south into continental Europe, west across the North Atlantic to Britain, Ireland, Iceland, east along the river systems of Russia, all the way to Constantinople. This wasn't just raiding. This was systematic colonization, settlement, the establishment of permanent Norse communities in dozens of territories across 3 continents. And everywhere they went, they brought their genes with them, including MC1R variants. The genetic impact was staggering. In Britain, particularly in areas of heavy Norse settlement like Yorkshire, the Orkneys, and the Scottish Highlands, modern populations show Norse genetic markers at frequencies up to 40%. That's not just a few Viking raids. That's population replacement, extensive interbreeding between Norse settlers and local populations over multiple generations. And with those Norse genes came red hair. Studies of modern British populations show a direct correlation between areas of heavy Viking settlement and higher frequencies of red hair today. The distribution map of red hair in Britain isn't random. It follows the Viking settlement patterns almost perfectly. Highest concentrations in Scotland and Ireland, where Norse presence was strongest. Lower frequencies in areas the Vikings largely avoided. But here's where it gets really interesting. The Vikings didn't just spread red hair genes passively through settlement, they actively valued them. Norse culture, unlike many others, seems to have viewed red hair as something notable, perhaps even prestigious. Consider Eric the Red, one of the most famous Vikings in history. His nickname wasn't an insult or a mark of otherness. It was his identity, the name by which he was known across the North Atlantic world. Eric Thievalsen became Eric the Red, and that name carried weight. He used it. He was famous under it. He founded settlements under it. When Eric established the first permanent North settlement in Greenland around 985 AD, he did so as a red-haired leader whose appearance was considered noteworthy enough to become his defining characteristic, yet also acceptable enough that it never hindered his ability to lead, to inspire, to convince hundreds of people to follow him to one of the most inhospitable places on Earth. And he wasn't unique. Norse sagas are full of red-haired characters, not presented as oddities or supernatural beings, but as ordinary people whose hair color was simply one more physical descriptor, like height or build, quote 1, quote 2. These names appear throughout the historical record without any suggestion of stigma or supernatural association. This matters because it suggests the Vikings were doing something different with red hair than many other cultures. They weren't mystifying it, demonizing it, or romanticizing it. They were normalizing it, treating it as natural human variation worthy of note, but not of fear or worship. The Norse expansion into Russia reveals another chapter of this genetic story. Swedish Vikings known as the Russ established trading posts and eventually principalities along the river routes connecting the Baltic to the Black Sea. These Norse populations settled, intermarried with Slavic populations, and eventually were absorbed into the developing Russian culture, but they left genetic traces. Modern Russian populations, particularly in the northwestern regions around Novgorod and Kiev, show Norse genetic markers, including MC1R variants.